Today video tutorial is related with the Solidworks simulation, finite element simulation, and here we're gonna see how to assemble two different parts and then do the simulation. So the reason to bring assembly here, because in the class we didn't show how to assemble two things or two parts together. So this video tutorial gonna serve two different things. One is how to do the assembly in SolidWorks and how to do the finite element simulation in SolidWorks. So here when we wanted to assemble two different parts, so previously we have seen that for part design we are doing some kind of part design here, and now we wanted to do assembly design. So assembly design is here. So for doing the assembly design, after opening the SolidWorks, so we have to click here and it's gonna open the assembly drawing. Then SolidWorks gonna ask what parts we wanted to assemble, and based on our previous drawing we're gonna select the folder. So you see automatically it shows the assembly drawing and the specific folder, because previously I have done this folder, so SolidWorks automatically select this folder, but if your folder is somewhere else you can select from here. So I'm just selecting, we wanted to assemble this column and this beam. So we can do it one by one, but I prefer to do it two in one shot. So open. And you see, it brings our two parts in the window. So now what we wanted to do, I made the drawing such that this particular diameter has the same diameter of this one. So we wanted to first bring this beam to this particular part and joining together, and then we're gonna run the simulation. So we wanted to put loads on this particular beam and see how it works within the applied force limit. So for doing this we wanted to do the mate. So you can do it from here, or so assembly, if you click also from here, you can find here the mate. So let's click here. Okay, so you can see here nothing is it's empty. So when you are clicking this one, so it select the beam, and when you are so we wanted to bring it this beam here. So in that case we need to select the hole. So if I make it bigger, so this hole we need to select, and it's bring together. So let's say, but you see we wanted to, it took somehow it's bring somehow in the middle, but we wanted to have this surface, the surface of the beam and surface of this part are in the same place. So we wanted to align these two parts together. So in that case, you see nothing is selected. So if you select this one with left mouse click and select this side, so it's automatically bring the both part in the same bring or align these two parts together. So now we do not need to do anything else, because if you have more parts, then you can also join and as per your requirements. So we're not gonna do we're not gonna join any other part. Therefore we can click finish. So your assembly is more or less finished here, and we will click OK. So now you see our part is joined together. So now what we need to do, we wanted to simulate. So this is the simulation. So if it is not appearing in your Solidworks user interface, then you can bring it from here. Sorry, no, it's from here. So if you go to the add-ins, so there all the add-ins are there, that is not selected or not automatically bring to your user interface. So when you wanted to use it, just click here and bring it and click OK. Then it will pop up into your main window. So I already have done this, and there are many other add-ins. So Circuitworks, Solidworks Motion, and there are many so far. Okay, so if you click here Motion, then you need to create a new study. So I click new study, so you can make any name. So maybe you can call it study 1. Study 1 maybe. And so here you can do so many things, thermal, buckling, fatigue, nonlinear. And here a design study also, you can analyze your design, and topology study. So topology study normally we need to do when we wanted to reduce the weight of the structure without compromising the load bearing capability. So let's say if we wanted to design some structure that's supposed to withstand 200 kilos of load, and maybe the structure is something like this, but still we can take out some materials from different parts that is not related to the that will not actually compromise the total load bearing capability. So let's say if we take out some materials from here, it may be not influence the total load bearing capability. And in topology study, you normally select this kind of parts, and then it automatically shows you what types of materials or which part of the materials you can take out from your study. And you can draw in this way, and there are some also video tutorial in YouTube. You can see how to do the topology study. So this is this is the thing what we are not doing in this study. However, we wanted to only interested into the finite elements simulation. So let's click and you see so this is the things we need to follow one by one. So part, we already selected the part. Connections, so far this is most of the time is not necessary, it is predefined. And then we need to do the fixtures. So fixtures, if you right click, so fix geometry. So we wanted to actually fix the geometry, so there are more options, and those options are related to different use cases. So we wanted to do the fixed geometry. So one geometry or one part is fixed, and we're gonna apply to load here. So we have to make this part fixed, and let's say fixed geometry. And yeah, we can fix the whole geometry, but I assume that this particular part is attached with the ground, so our interested fixed part is here. So we're gonna make this, click this one, and you see it's automatically select this face of the part. Click OK, and it's more or less done. And then you need to put the load. So let's say you wanted to create force, and there are different types of load: force, torque, pressure, gravity, centrifugal, bearing load. So there are different kinds of load you can apply based on your requirement. However, we are interested in force. So left mouse click force. Okay, so now it shows like where we wanted to apply the force. So we can apply the force here. So that is necessary when you wanted to see how much, if you welded this part, then how much force can withstand this particular structure. But we wanted to actually put loads here and see how the structure actually work on this this type of load. So apply load, and in SI unit we, I don't know, let's say or considered load is 6,000 Newton. Okay, and then click OK. So if you wanted to also put load here or some other parts, that is also simultaneously you can select, and here you will see different faces will be selected. So then OK, and with different arrows it shows like where you are putting the load and which part is fixed. So now our load is applied, and we wanted to do mesh. But I would suggest before doing mesh, we should select the materials, because our system doesn't know that what sort of materials we have been selected. So here we can select different materials for these two parts, or select similar materials for two parts. So to avoid complexity, we're gonna select same materials for these two parts. And for selecting materials, we need to right click in the part, and you see apply materials to all, apply favorite materials to all. So I don't know if you wanted to do the apply materials to all. There are a big numbers of materials, you can see doesn't pop up anything. It takes a little bit time. Okay, so now you can see there are good numbers of materials, even though if you have a specific materials that is not included in Solidworks, you can add the properties on your own, and the system will calculate based on your input. So I don't know, maybe we can put alloy steel and then apply, and it has been applied to the hole. Close, and you see it also changed the color based on your materials. And now we wanted to create the mesh, and here you can do mesh and run together. So after doing the mesh, it will automatically run the simulation and create mesh. You can do only the mesh, so it's up to you. So let's say we should do it separately. So create mesh, left click, and you see here you can do the fine mesh, or like a little bit less amount of mesh. So here your simulation quality mostly depends on your mesh quality, and most of the time, if you have enough computational power, so if your computer can handle if your computer has higher configuration, then it's better to always put the fine mesh. Other than it depends on your requirement also. You can also use the medium one, but for finite element analysis it is not really a problem to do the mesh. As soon as your computer can handle Solidworks, I think it can also handle the meshing capability, because for finite element analysis of this small part, it's not really difficult for the computer. Click OK, and you see it start to creating the mesh, and you see it's create mesh, and the applied load will be every single part of this triangle. So yeah, now you need to run the study. So here you should run, or maybe let me check from here also. No, run is not possible from here, so you have to run from here. So left click and run the study, and the study start to run. So you see, and this study has been done on von Neuss theorem, and you see the yield strength is there, and the red is the critical point, and the blue is non-affected parts. So you can see the overall structure where you applied the loads, and you see also inside the structure, but it affects less based on the color. And if you wanted to see some kind of animation, so right click and animate. So the stress level we can animate, and you see, so if we make it like this, then you can see how the load is actually transferring from one point to another. Okay, then if you wanted to see the displacement, click the displacement. And right click and show. So now you see this is selected, and again right click, and if you wanted to also see the animation, you can see here. So where is the displacement is taking place in it's in the last part of the rounded object. Then if you wanted to see the strain, you have to also right click and show. Now it will select the strain, then again right click, and you can do the animate. You can do the mass sectioning. There are different things you can do here. So just wanted to show how so this is how it's affecting. Okay, so that's all. And when you think you are finished with, so you can actually finish here. Other than you can make different study or different simulation, and you will see here you will have, let's say if you have second study, you will see another tab here, and you can still compare two different study in the same part here, and you can when you see that you are finished with your simulation, just make a report. Then you should click on this one. So this is the report part, and if you click here, it will automatically save the document as Word document there, and I would like to have the A4 size paper, and yeah, maybe I would like to select a specific folder. So select folder, and if you click publish, you can actually select and deselect things according to your needs. Yeah, it's up to you, but I'm just trying to keep it default, and here publish. And now the system is writing the report. And in your third third assignment, you need to show this kind of report as well for the simulation, and I think it's really very easy. Of course, do not provide us the report what automatically produced by the system or produced by Solidworks. Rather, you need to rewrite the report, because some part, I will show you also when the report is finished, some part on the Solidworks report is not really well written or well organized. Therefore you need to do it on your own. let's say a description. So there is no data, so you should write some sort of description of the document, like what you have done. It's maybe a little abstract, or at least a title maybe there. And what was your assumption? So assumption was not really needed, rather than you can write something here, that interaction, like what you wanted to do, or yeah, it's up to you. Then you see the model information, everything is more or less there. So connector definition, this is not needed for our cases. So this is mesh information, what sort of mesh you have done. So every information is there, and it is important. The screenshot of the mesh and sensor details, we didn't put any sensor inside the simulation, so there is no sensor information. And this is the forces information, what sort of force you're gonna apply. Then the beams information, so maybe you can put the 3D dimension of the beams, maybe like this is one of the part. Then the study result, so this is the result. And so this is 3 types of result. You see the stress, strain, and displacement. And conclusion, so this is not automatically created, because the system doesn't have clear idea about your requirements, so the conclusion is supposed to be written by you. Yeah, this is the documents, and I would like to close this one and show you something else. So there is another thing quite interesting. If you click the evaluate, and if you wanted to see the costing, which is quite interesting. So if you click here, the costing, it will pop up some information on costing. So so there are this is they have already costing template, Solidworks, and you can also make your own template and insert here. But let's go with the default option and begin cost estimation. And you see it shows that with the selected materials, if we produce 100 units, then the cost will be 11.68 USD per structure or per part. You see, if you reduce the numbers, let's say you see it's 11.69. if you reduce this number 10, and you see it's 12.58. if you total number maybe 1000, then you see it's still 11.59. So this is the way you can also have a visual overview about the costing. Like, it's not only the designing, it is also giving you some output or some notion about the costing. So I would like to finish here. There are many things also you can do, which is not really possible to show you within this short time frame. However, that's all, and see you in the next class.